Hello everyone, today we are traveling 12 billion light-years across the cosmos to unlock the story of J0529-4351, the single brightest object humanity has ever observed in the entire known universe. For decades, this cosmic behemoth hid in plain sight, mistaken for an ordinary star in our own galaxy, while it blazed with a fury no other celestial body can match. This is not just a quasar, it is a record-breaking monster, powered by the fastest-growing supermassive black hole ever found, a celestial engine that reshapes our understanding of how matter, energy, and gravity behave in the extreme corners of space. Let us begin this journey with a sense of awe, for what we are about to explore defies nearly every scale we use to comprehend our universe. To grasp just how bright J0529-4351 is, we must start with our closest star, the Sun. Our Sun sustains all life on Earth, radiates enough energy to power our planet for billions of years, and shines with a luminosity that defines our solar system. Now multiply that brightness by 500 trillion. That is not a typo, 500 trillion times the light of our Sun. Every second, this quasar releases more energy than our Sun will produce over its entire 10 billion year lifespan. If we could place this quasar at the center of our solar system, its light would instantly vaporize every planet, outshine the combined glow of every star in the Milky Way, and be visible clear across the observable universe. This level of radiance is not just extreme, it is unprecedented, making J0529-4351 the undisputed champion of cosmic brightness. Before we dive into its staggering power, we must understand what a quasar actually is. Short for quasi-stellar object, a quasar is the brilliant core of an active distant galaxy, driven by a supermassive black hole at its heart. Unlike the black holes we often imagine, silent, dark voids, these supermassive giants are surrounded by swirling clouds of gas, dust, and stellar debris, called an accretion disk. As gravity pulls this material inward at nearly the speed of light, friction and compression heat the disk to temperatures of trillions of degrees, converting matter into pure blinding radiation across the entire electromagnetic spectrum. This process turns a black hole, the darkest object in the universe, into the brightest engine in existence. And J0529-4351 takes this phenomenon to an entirely new level, pushing the laws of physics to their very limits. The story of how we found J0529-4351 is as fascinating as the object itself. For more than 40 years, astronomical surveys captured its light, but automated algorithms and even human astronomers labeled it an ordinary star within the Milky Way. In 2022, data from the European Space Agency's Gaia satellite gave it a 99.98% probability of being a nearby star, a classification that hid its true nature from the world. It was not until 2023 that a team, led by astronomers from the Australian National University, noticed inconsistencies in its light signature. Using the 2.3-meter ANU telescope at Siding Spring Observatory, and later, the European Southern Observatory's Very Large Telescope in Chile's Atacama Desert, they peeled back the layers of misclassification and revealed a distant quasar unlike any other. This discovery, published in Nature Astronomy in February 2024, rewrote the record books and stunned the astronomical community. Located in the Pictor constellation, J0529-4351 sits 12 billion light-years from Earth. The light we detect today left this quasar when the universe was less than 2 billion years old, just a fraction of its current 13.8 billion-year age. This makes it a window into the early universe, a time when the first galaxies were forming and supermassive black holes were growing at breakneck speeds. Studying this quasar does more than break records. It helps us answer fundamental questions. How did supermassive black holes form so quickly after the Big Bang? How did they shape the galaxies that surround them? What limits exist for black hole growth and cosmic luminosity? J0529-4351 holds clues to every one of these mysteries. At the core of this extraordinary quasar lies a supermassive black hole with a mass of approximately 17 billion times that of our Sun. To put that in perspective, the black hole at the center of the Milky Way, Sagittarius A, multiplied by, is just 4.3 million solar masses, meaning this quasar's black hole is nearly 4,000 times more massive. But its mass is only part of the story. Its appetite is what truly sets it apart. This black hole accretes, or consumes the equivalent of one entire Sun's mass every single day. Over 1 year, that adds up to more than 365 solar masses, making it the fastest-growing black hole ever observed. This relentless feeding frenzy is what powers its unrivaled brightness as the infalling matter releases an incomprehensible amount of energy before crossing the event horizon, never to return. The accretion disk surrounding this black hole is equally mind-blowing in scale. Stretching 7 light-years across this swirling disk of superheated gas is wider than the distance from our Sun to the nearest star system, Alpha Centauri. Most accretion disks around quasars are a fraction of this size, making J0529-4351's disk one of the largest ever recorded. The material in this disk moves at velocities approaching the speed of light, creating friction so intense that temperatures surge to trillions of degrees. This extreme heat generates radiation across gamma rays, X-rays, ultraviolet, visible light, infrared and radio waves, creating a glow that cuts through the darkness of intergalactic space, like a cosmic lighthouse. Even from 12 billion light-years away, its light is powerful enough to be detected by our most advanced telescopes. What makes this discovery even more significant is that it challenges our existing models of black hole growth. Astronomers have long used the Eddington limit, a theoretical boundary that describes the maximum rate at which a black hole can accrete matter without the outward pressure of radiation blowing the material away. J0529-4351 appears to operate near or even at this limit, a feat that was thought to be extremely rare in the early universe. This means our models of how supermassive black holes evolved may need to be revised, as this quasar shows that extreme growth was not only possible, but common in the universe's youth. It also suggests that there may be more of these ultra-luminous quasars waiting to be found hidden by the same misclassification that masked J0529-4351 for decades. As we contemplate J0529-4351, we are reminded of the vastness and mystery of the cosmos. We live on a tiny planet, orbiting an ordinary star in a modest galaxy. Yet, our curiosity and ingenuity allow us to detect and study objects that existed billions of years before Earth even formed. This quasar is more than a scientific curiosity. It is a testament to the universe's ability to surprise us, to push the boundaries of what we think is possible, and to fill us with a sense of wonder that drives exploration forward. Every time we break a cosmic record, every time we discover an object more extreme than the last, we take another step toward understanding our place in the infinite expanse of space. The discovery of J0529-4351 also highlights the importance of persistence and re-examination in science. For nearly half a century, this object was overlooked because it fit a familiar pattern, a reminder that even the most advanced automated systems and established classifications can miss the most extraordinary truths. It took a team of curious astronomers, willing to question the data, to look closer at an object everyone else ignored, to uncover the universe's brightest gem. This lesson applies not just to astronomy but to every field of human discovery. The greatest secrets often hide in plain sight, waiting for someone to ask, what if we were wrong? Looking to the future, J0529-4351 will continue to be a prime target for our most powerful space and ground-based telescopes. The James Webb Space Telescope, with its infrared sensitivity, will peer deeper into its structure, capturing details about its accretion disk, its host galaxy, and its environment in the early universe. The VLT and other ground-based observatories will monitor its brightness and activity tracking changes that could reveal more about black hole physics. Every observation will add to our knowledge, turning this distant quasar from a mere record holder into a key that unlocks the earliest chapters of cosmic history. We often talk about superlatives in space, the biggest star, the farthest galaxy, the smallest black hole, but J0529-4351 stands alone as the brightest object we have ever found. It is a beacon of light in the dark, a monster of gravity and energy, and a teacher that expands our understanding of physics. It reminds us that the universe is far more powerful, more dynamic, and more amazing than we can ever imagine. As we keep looking up, as we keep building better telescopes and asking bolder questions, we will undoubtedly find more objects that challenge our perceptions. But for now, J0529-4351 reigns supreme as the universe's most luminous wonder. As we wrap up this journey to the farthest reaches of space and time, let us carry with us the awe of this incredible discovery. The cosmos is full of secrets, And every time we uncover one, we connect more deeply with the universe that surrounds us. J0529-4351 is not just a quasar. It is a symbol of human curiosity, of our drive to explore the unknown, and of the infinite wonders waiting for us beyond the stars. Please like, comment, share, and subscribe to the channel.